and solving them using the Fundamental Theorem of Calculus, which means we're looking for the definite integral. And I have this problem right here to be sort of a warm-up. So you have the integral from -2 to 1, 2 over x squared dx. And I want you to stop and think about what's wrong with this problem. And I'll pause. If you said it cannot be solved, you are correct, and I'm going to show you why. So when you have the interval -2 to 1, you're actually including x equals 0. And if you stop and think back to the first semester of calculus, when you have a number over a 0 squared, which we know is a number over 0, we know that to be no, which means that there's a discontinuity there. Now the thing about definite integrals is you can only solve for a continuous function. So this function cannot be solved because it is not continuous. Now we'll move on to question number 2 because it actually can be solved, and I'm going to walk you through that. So you have the integral from 4 to 9, 1/3 times the square root of x dx. So I'm just going to write that square root of x as x raised to the power of 1/2 just to make it easier for me when I integrate. So you have that integral from 4 to 9, 1/3 x to the power of 1/2 dx. Now I'm going to integrate, so this problem becomes now a function of x is equal to, you're going to add 1 here, so you have x is 3/2, and then rather than dividing 1/3 by 3/2, you can actually flip this 3/2 here to 2/2, which means we're using the reciprocal here, and you can multiply these equations. It makes it a whole lot easier for us. So when you flip it, you're going to get 2 over 1/3, 3, 2 over 9, which is a little bit of a wonky number, but we're going to work with it. So now we're going to plug in our two values right here, our b and our a. So you have the function of b, which for us it's 9, minus the function of a, which is 4. And what that simply means is we're going to plug in this 9 and this 4 for our x value, and we're going to solve. So we have the function of x is equal to 2/9, and then you're going to plug in 9 raised to the power of 3/2 minus 2/9, 4 raised to the power of 3/2, and I'm just going to pull out my handy dandy calculator, and I'm going just to do 9 raised to the power of 3/2, and you're going to get 27. So I'm going to rewrite all this in a little bit of a simpler way. You're going to get 2/9 times 27 minus, and then we're going to do 4 raised to the power of 3/2, and you're going to get 8. So 27 minus 8. So what I did is I pulled these 2/9 out to the front, and we're going to subtract these, then multiply this by 2/9. It's just as easy. So I am going to distribute. So we're going to have 27 times, oh, nope, not that. 27 times 2/9. And you're going to get 6. So 6 minus, and then you have to do that minus 8 because that's where that minus is, times 2/9, and you're going to get 6 minus 16/9. So then if we take this and we do what's going to be 6 over 9, so you have 9 times 6, which is 54. So it's 54/9 minus 16/9. So we'll take our 54 ninths minus our 16 ninths, and you're going to get 38 ninths. That is your definite integral. Put a box around it and you can call it a day.